Hi, Steven.
Hey, how's it going?
Hey, good enough for you.
Good. Good. Um, I don't know. I don't see your screen.
Let me share my screen. Give me a second.
Oh, okay. Oh, okay.
Right.
Cool.
I think we can get started. It's just you and me right now, so you can ask me questions.
Okay. Cool. I had questions on the chapter 6 exam worksheet.
Chapter 6.
The electronic configuration, multiple choice worksheet.
I am on. Good morning.
Hey, good morning, Nick. Yeah. So which one? Which question?
So it's one of the ones towards the end. So really, I think it was 33.
33.
33. And then also, well, we can just do that one first, I guess, and then Nick can go.
So here it's saying that mole of red photons of wavelength. So you're given wavelength basically, and you have to find energy in kilojoules.
Mm-hmm.
So first you can find it in joules and then change it to joules. So do you know what equation to use here?
No, I don't. Well, okay, so I know the wavelength symbol is
Right.
it's like mu, right? Is what they call it.
It's a lambda. Mu is the frequency symbol.
Oh, okay. So lambda is
Yeah. So in your lecture notes, try to look for the formulas that I've given you. So there were a couple of formulas. There was C is equal to lambda times frequency.
Okay, yeah, I had that one here. Yeah, and
Look
then
for the one that was delta E. Delta E is equal to
delta E.
H over lambda.
Was that one of the first ones you gave us?
I think this was the second one. It was on the same day, but
it was a little bit later.
Yeah, it should be on same page or next page.
Okay, so E equals H times V.
H times C over lambda. So you can see on the screen right now.
Mm-hmm.
So the first one is C is equal to lambda times frequency.
Okay.
Then yeah, so see that's formula number one.
Mm-hmm.
Then formula number two was E is equal to H times frequency. That's the one you were.
Yeah.
And the third one is this one. The third one actually came from first and second, because if you combine first and second one,
okay,
you will get the third one.
Okay.
Because you can hear that E is equal to HV, right? H frequency.
Mm-hmm.
So E is equal to H times frequency. So from here, can you isolate frequency?
So frequency equals C divided by V.
By lambda, not V, right? Lambda. This is lambda. I'm isolating this guy.
Oh, okay. Lambda. Okay.
Right.
Sorry. Yeah.
So frequency is equal to C over lambda, right?
C over lambda. Yeah.
So I changed that frequency to C over lambda.
Mm-hmm.
So this and this formula, they're the same formulas, right?
Yeah.
E is at C over lambda. So basically, you have three formulas.
Okay.
Okay. So erase this.
There.
Now, which one do you think we should be using here in this case?
Two. Or so it's not asking.
It's giving you wavelength.
Okay, so because 2 doesn't have lambda in it, so that's why you're using.
Yeah, we'll have to use the third one because this has lambda.
Okay.
Now, C is a constant, H is a constant. So you'll not be given those in the question, you'll find them on the reference page.
I'm confused because I don't see any like initial, so it's asking for delta E?
It's basically looking for E, so never mind. You can ignore that. It's not delta E, it's E.
It's just E. Okay.
So E is at C over lambda. H we know is a constant, 6.626 times 10 to the power negative 34 joules seconds. This is 6. And then C is 3 times 10 to the power 8 meters per second.
Mm-hmm.
So you plug in the H, you plug in the C, and then you're given lambda, which is 725 nanometers. You got to change it, of course, into meters, right?
Because of the C.
Yeah, because lambda is 725
Okay.
nanometers, and this guy is in meters, so we got to change it to meters. Nanometer goes here, meter goes here. 1 meter has 10 to the power 9 nanometers. So you got 725 times 10 to the power negative 9 meters, right?
Yes.
So you got your lambda. Lambda is this. H is this. Sorry. H is this. C is this. You want to find E, so you just plug in everything. So 6.626 times 10 to the power negative 34. It's joules seconds times, let me open this more. Okay.
Divided by 7
times, where's times C, right? Times 3 times 10 power 8 meters per second. And it's per second means second is going to go down here. And then we got lambda, which is 725 times 10 to the power negative 9. So our seconds, and then this is of course meters. Our meters cancel, seconds and seconds cancel. Joules, so how much would that be? You have to plug that whole thing into calculator.
So I got 0.02741, and then there's some more numbers after that.
And then times what?
So it's negative 34 plus, hold on a second.
Plus 8.
Plus 8, and then plus 9 also.
Right.
So negative 17 times 10 to the negative 17.
So that's what it looks like?
So it should be A then, right?
And that's in joules, right? No. Wait. That's first of all, and there's one more thing.
Okay.
So first, let's change this to kilojoules. So if I keep the number same, because the answer is looking in kilojoules.
Yeah.
So this will become 10 power negative 20 kilojoules.
Okay.
That's one thing. Right now, we have just changed it to kilojoules. Now, do you see the question actually says that we have 1 mole?
So it's a mole of red photons.
Right. The number that this is for 1 molecule, 1 photon. You see that?
What number? Oh, the final answer?
Yeah, this number that we got, 0.02741 times 10 to the power negative 20 kilojoules. This is kilojoules per molecule.
Okay.
The question is looking per mole, right?
Yeah.
So we got to change this kilojoules per molecule to kilojoules per mole. So kilojoules, we don't touch it. We just want to touch molecules.
How do you know that it's kilojoules per molecule?
Oh, because the question is saying that. You see here?
Mm-hmm.
A mole of red photon of wavelength 725 nanometer has dash kilojoules of energy.
Mm-hmm.
It's looking for mole, that a mole will have how much energy, right?
Oh, okay.
So if we read the question carefully, it is saying that tell me the energy, not for 1 molecule, not for 1 photon, but for a mole of a photon.
Yeah.
Right?
Mm-hmm.
That's why we're doing this. Does that make sense?
Yeah, that makes sense.
Okay. And then whenever you find these energies, E is equal to H or lambda or E is equal to H frequency, that is giving you energy of 1 molecule or 1 photon.
So you just know that it's a molecule.
Yeah, that you got to remember that the energy that we find is for 1 photon.
Okay.
Okay. Okay. So here we have molecules, and bottom we will put the moles rate.
Mm-hmm.
And we know that 1 mole is.
Is this still Avogadro's number? Even though. Okay.
Yeah. It's still this mole is still the mole.
Okay.
Yeah. So if you now multiply those two numbers, what do you get? Calculator.
0.027.
You can leave the exponent out if you want.
It's 0.1650.
0.165
Yeah.
times 10 to the power negative
Yeah, times 10 to the power 3.
10 to the power 3. So this answer is 165, right?
Yeah.
5 kilojoules, and that's the answer, right?
Yeah, it is. Okay.
165 kilojoules per mole. And that's what we see. And this is similar to, did you guys did lab 21 with Scott, right?
Yes.
And there was that question that how much kilojoules per mole is it for die 1 and die 2? And there also you guys did a similar calculation. So this is similar to that.
Okay. I don't think we did that one actually because the thing we had to look through wasn't working.
Oh, what was not working?
Remember, well, we had an object that we had to look through at the light, and it wasn't working correctly, so we had to do
It was
that.
not that one. It was actually the other one where you combined the dyes and you saw light.
Oh, okay. Okay.
Yeah. So it's on the very first page of Lab 21 on your report sheet page.
Okay.
The very bottom, the last question on the first page of your report sheet.
Okay.
Yeah. So if you want to practice that, you can do that as well.
Definitely.
Yeah. All right. I think you got more people. I'm going to take more questions, guys. Do you have questions?
I do.
All right. Where? What? Any questions on? We'll first stick to this worksheet.
Yeah, it's on this worksheet actually.
Okay.
The part I'm getting stuck on, I've done some of these problems already, are the ones with the arrows that go up and down.
With the orbital diagrams, you mean?
Yeah.
What about them?
I'm not, like, there were a few that I did, and I still didn't quite understand the question. Because it's saying, like, which one wasn't.
So first of all, you gotta quickly tell me for S, how many boxes do we have? How many boxes do I make for S?
Don't you have, like, don't you have 2 boxes for S? Because you can only have 2 S's, right? At the most, right?
No, you can have 2 electrons in one S. Or, I mean, if you're on the S room, on whichever floor you're on,
right,
you can fit in 2 electrons, which means 1 box.
right.
For P, it means 3 boxes. For D, means 5 boxes. So you first gotta make sure that you understand this basic stuff before you do any worksheet. Okay?
Okay.
So then F has, you'll never need F, but just to know it has 7 boxes.
Right.
Is that 7? Yeah. And then each box can take 2 electrons. So I'm right now telling you guys the rules, okay? Each box can take 2 electrons. If I have to put, let's say, 4 electrons, or let's start with 2 electrons, okay? So how do I put 2 electrons in P? Nick, can you answer?
Don't you have to put 2 electrons in the first box?
No. You put 1 in the first box, and then you put next in this next box. So you put the first one here, then you put the next one here. If there is space, if there's enough space for you to give each electron its own room, it will go into its own room.
Okay.
Now, if I have more electrons, let's say I have the same P, but this time I have 4 electrons. So I'll first do this. I'll give 1 here, 1 here, 1 here. That's 3 electrons. And my 4th one will then go to the first box.
Right.
Okay. Does that make sense?
Yeah, because like when I was doing 5 and the rest of them with those, it was asking for the violations of the Pauli exclusion principle.
Uh-huh.
and I chose C because you can't have in your 2s, you can't have 2 arrows pointing up in the same direction, right? 2 electrons you can have going in the same direction, right?
Right.
And why And why is that, Amon?
Imagine that there are two electrons. Two electrons, whenever they're close to each other, they have opposite spin.
Right.
We don't go into that much detail in this class, but
Right.
that's what if you want to just get some idea, that's what it is.
Okay.
Arrow means the spin, whether the electrons are moving clockwise or anti-clockwise. Their magnetic field is clockwise or anti-clockwise. They cannot be same for both the electrons in the same box.
Right.
Okay.
Makes sense.
Hi, Harvey.
I think Chelsea Sanchez, whoever that is me.
Is that Chelsea?
So yeah.
Okay, I'll just mute.
I was about to say that. Where's that coming from?
Yeah, I think that's Chelsea. Okay.
Yeah.
All right. So, guys, more questions?
Yeah. Let's see what else I got. Let's see if I got one more. Well, ask somebody else first, the one while I can find my question.
Anyone else have any questions, guys? So, Alex, you have question on 22, 23. So the question is saying which one is not a valid set of 4 quantum numbers? So the first is N, L, ML, and MS. Which one is not correct? So let's see the first one. So the first one says that your second, N means 2, 2 means it's the second floor. On second floor is a value of 0 for L possible?
Can be, right?
Yes, it is possible because L is equal to any number and you stop at N minus 1.
Okay.
Right? So that means 2 and 1 is also possible. 3, 1 is also possible. 1, 0 is also possible. But you see the last one, 1, 1, that's not possible.
Why is it not? Because it goes up. Because it goes above -1.
Not negative. Yeah, N minus 1, not negative 1. See, if your value of N is equal to 1, then what is the value for L? L is equal to N minus 1, right? It stops at N minus 1. Right?
As it stops.
You guys
I'm just
remember?
writing a note of that.
Because it has to be one less than
right. N
1
is equal to 1, 2, 3, 4, or whatever. L is all the numbers from 0, 1, 2, 3, all the numbers, but it has to stop at N minus 1. That's its maximum cap.
Why is that? That's just how it is?
Yeah, these are just the rules that are made, okay? Just to get some, these are all observation-based rules. They're observations. They're not like, these are not things that govern how electrons are going to fit in or what rules electrons are going to follow. This is more like the observations that were made. So N, L, and then ML is negative L to positive L, and then MS has 2 possible values, plus 1/2, negative 1/2.
That's M delta, or what is that? Or MS? What is
MS.
that? MS? Okay.
We don't ever have to worry about that one though, really, right?
Yeah, MS, it's either plus half or negative half. So you never worry about that, yes. Okay.
I'm just wondering, are you still going to show us the rest of chapter 6 tomorrow or no?
The rest of, what do you mean rest of chapter 6?
Because you said that there still was a part of chapter 6
There's one topic left. I'll probably come back to that maybe. So first I want to finish, more...
The Lewis structure?
Yeah, I want to cover more difficult stuff first so that you guys have time to study that.
Okay.
And then if I have like small topic left, they're not less important, but they're smaller topics that you can quickly grasp on.
Okay.
Lewis structure is something where you need to spend time in order to do well on the exam.
All right.
That's why I want to do those first.
So, Amon, is it the same thing too for 23? Is it similar to that 22 problem?
So 23, yeah, 23 is also similar. First of all, let me ask Alex, did that 22 make sense? If there were just possible sets and not or only solution. All right, cool. Yeah. Right. So here in these questions, it's just asking which one is valid, which one is not valid. That's all they're asking.
Right.
Right. So here we can see the last one is this is not valid because a value of L equal 1, which is equal to n, is not possible because it stops at n minus 1. And if you look at number 23, which set is valid? So here, let's see. 2, 1, 0 plus half. Does that look valid? Yeah, that looks valid. Everything's right. Because this number is less than 2. That's good. This number is within the negative L to positive L range, which is negative 1 to positive 1 range. That's good. And this is plus half, which should be good. Let's look at this one. This one is incorrect. You see? 2 to 2. That's not possible. Can you guys tell me what is wrong with the C?
But see,
ML.
one's greater than 0, and it shouldn't be like that.
ML is the problem. N is 1, and then L is 0. That's good because n minus 1, so it should stop at 0, and it is 0. But this guy, ML has to be 0 as well, right? Because ML is negative L to positive L. If L is 0, then ML cannot be 1.
Right.
Right? And then if you look at this one, 2, 1 plus 2, what is wrong with this one? Same
The
thing.
same thing. Yeah.
Same thing. 2, 1 is possible, but this plus 2 is not possible. The range for ML is plus 1 to negative 1 to plus 1. So this plus 2 is not possible. And if you look at this one, what's wrong with this one?
L.
Yeah, the
No.
L. This is 1, and so this should be 0. This cannot be 1.
So they're always going to be the same. If it's 1, if the first one's 1, then it'll be 0, 0.
It has to be 0, 0. There's no other option.
Yeah.
So I'm on L, but L is 1 in this case on the A one.
You know, on E?
No, on A on 23.
On A, right?
Yeah.
So what are you trying to say?
But that's why you kind of confused me a bit. You said E is not supposed to be 1 in that case for E, but on A it's 1 after the 2.
Right, which is possible, right?
Right.
What is the rule for L, Nick?
It has to stop at 0, right?
No.
Or at 1.
It
Has to
has
stop
to
at
stop
1.
where?
At 1.
No, what does it say here? L
L
stops at n minus 1.
n minus 1. Okay.
So it depends on n.
All right.
So if n is 2, this first number is n.
Right.
So it has to stop at n minus 1. What is n minus 1? What is 2 minus 1?
1.
1. So it has to stop at 1. And
Okay.
it is giving me 1, so which is possible.
Okay. All right. Because now I see what you're saying about E. Like E, it's 1, but that's supposed to be 0, right?
Right.
E
The
part
second
of
number
this
is
one.
supposed to be 0, but it's not. So that's why it's incorrect.
And then with C, it has a 0, but you said that's still not correct though after that because it's the ML,
The
right?
problem is here. Yes, then the problem is ML. ML has to be negative L to positive L. So if L is 0, then the possible value of ML is only 0.
Uh-huh.
But in this case, it's saying 1, so it's not correct.
Okay.
Now the question is, let's look at this one here. If you have 2, 1, minus 1, and plus half, is this possible, guys?
Which one?
Look here in the here.
21?
2, 1, minus 1, and plus half. Is this possible? So 2, you're on second floor. Is L1 possible?
Yeah.
Yes. It has to stop at n minus 1, right?
Mm-hmm.
Mm-hmm.
That is possible. Is it 1 possible?
Well, it has to, yeah, because it has to be between negative
Yes.
1
So
and
ML
positive
has
1.
to be any number from negative 1 to plus 1. And it is negative 1, so that's good. And this guy is plus half, so that's good. Right? So yes, this is possible.
Were you doing the same problem, or which one were you looking at right
Yeah.
now? That,
Yes,
He's looking at the chat.
Steven just gave out a question where he has, is this going to be possible or not? 2, 1, minus 1 plus half. It's in the chat. So,
Okay.
yeah. All right, guys. More questions, guys? Steven, is that good? It made sense? Steven Wilson? All right, great. All right, guys. More questions?
What other chapter did you say was going to be on the quiz?
on the quiz. Quiz is already posted, right?
Yeah, I can.
Yeah, I think it's just this
on
one.
chapter 6. It's just this chapter.
It's just chapter 6.
Yes.
Okay.
Hey, I'm on a question.
Yeah.
On number 8, on this worksheet, how come it says D as an answer for the P's because the electrons will keep on going the same direction for the 2p part?
For number 8,
Yeah.
so it's saying for nitrogen atom, which configuration looks right?
Right.
So for nitrogen is what? Nitrogen is, do you know the electronic configuration for nitrogen? Nitrogen has how many electrons? 7?
Yeah, 7. Yeah, that's right.
Do you know how to write the electronic configuration for nitrogen?
Well, you have to start with 1 electron first for the 1s.
So on the first floor, on the S, you give 2 electrons. Then on the second
Right.
floor, on the S, you put 2 electrons. S can take 2 electrons, okay?
All right.
So 1s2, 2s2, let's go to 2p.
All right.
In 2p, you already added 2 into 4 electrons.
Mm-hmm.
So there are 3 more. So 2p3, right? That's nitrogen electronic configuration.
Right. Okay.
1s2, 2s2, 2p3. 1s2, 2s2, 2p3. What is wrong with this one? What's wrong with option A?
They're not
Option
spread
A.
out.
Yeah, they're not really
Yeah,
spread
they're
out.
not spread out. So this electron pointing down should have been sitting here on the third box.
Right.
What's wrong with B?
With B, this 2s isn't going up and down like
This is
1s
also
is.
possible, right? That's not possible.
Yeah.
And what about the C? Problem is here. You see the first one?
Yeah, it's going in the same direction. We don't want that.
You look at, or D actually. This is D option. This one looks right. 1s2, 2s2, 2p3.
Right.
So that's why this is the E is the correct one.
Okay. Just wanted to make sure on that.
Hey, Mon, I have a question on a different worksheet, if that's okay.
Sure.
It's like an older one
Okay.
from the thermochemistry worksheet.
Thermochemistry worksheet.
The same, like multiple choice.
Okay. I'll again suggest you guys to work on 6, 7, 8, and 3 and 4. Spend most of your time there. Just a tip, okay? For your final exam, don't spend too much time on other chapters. You want to be pro at chapter 3, 4, 6, 7, 8.
Will there still be a little bit of nomenclature I'm on or no?
Yes, which is part of chapter 3, right?
Yes.
Yeah.
Yes. So chapter 3, 4, 6, 7, 8. That should be your focus. But yeah, you had a question?
Number 33.
Number 33.
Yeah.
Okay. Yeah, this is that question where you have to find the final temperature.
Yeah.
Right. So this is a question where you have to go in the opposite direction. So it says you're given mass for sodium hydroxide dissolved in 250 grams of water in a coffee cup calorimeter. Temperature increases from 23 to something, and then specific heat of the water is given. Delta H for solution is given this time. So this question is the opposite of the ones that we were doing. Remember coffee cup calorimeter?
Yeah.
You find Q solution first. Q solution gives you Q reaction. Q reaction gives you delta H reaction. This question is the opposite. It's giving you delta H.
Yeah.
So first find your Q reaction from here. Once you have the Q reaction, that will give you the Q solution. Once you have the Q solution using MC delta T, find delta T.
Okay.
And then from delta T, you know it's temperature final minus initial, and you're given initial, you can find
that gives us the final.
Right.
Okay.
So give it a try, and then that way.
I can try. We don't have to go over it. I think that makes a lot of sense.
Yeah. So if you just try it, and then if it doesn't work, then bring it to me. And
definitely.
All right, guys. More questions?
I have one, but I'm taking a little boys' room right now, break. So
Yeah, you have anything, guys, from chapter 6?
I still do, but right now I'm
Sure. I don't think anyone else. Anyone else have a question, guys? Yeah, I think you can ask Nick. You can ask a question.
yeah. I'm
Yeah.
gonna I'll be out in a minute. I'm in the restroom. So.
Oh, okay. Anyone have a question, guys? I'm waiting for you.
Yeah, I'm
I don't
making
have any other questions. That was it for me. I just had 2 questions.
Cool.
I have one electronic configuration, so I just gotta
So
I
chapter
just gotta
8,
find them.
guys, I'll try tomorrow, Monday, to finish the Lewis structures.
Mhm.
And then Wednesday we'll start and finish chapter 8. Chapter 8 is not that long. One lecture would be good enough. So I'll try next week to finish chapter 7 and 8. And
Hey,
then,
Michael.
yeah.
Quick, I was wondering too. Sorry to interrupt you, but I was wondering too. The labs 22 and 23 and 24. You said that's another practice for us we should do on this, right?
Yeah, it's like Lewis structure vesiper theory. Yes.
Okay. And the lab 6 and 7. Well, can we start that like next week during the dry lab for our section, or how? What should we do for that too?
You don't have to start it in the lab. I will suggest that you finish it yourself and then bring questions in the lab.
Okay.
Yeah.
All right.
I mean, the lab time probably might not be enough for you to finish.
Right.
I mean, I'm only this. This should not confuse everyone else. For one of my section, I have given them a lab 6 and 7 makeup lab. So I'm just talking about that. So the others, those who are not assigned that, don't get confused.
Right.
So there's that lab that you guys have to turn that in, and then yes, you can ask me questions anytime you want on that, but you should already be working on it.
Okay. Now here we are. Let's see. All right. Let's see if I find it.
For the quiz, should we expect questions about quantum numbers like worksheet and what you saw? Yes. I think if you work on this chapter 6 worksheet, that's what your questions should look like electronic configuration, and then quantum numbers, and then also the math questions that you see at the end, like these ones, like nanometers, joules, energy, all those kinds of questions as well. Electron jumping from 4th floor to 2nd floor or something like that. Right? So
Okay.
if you finish this worksheet, then you should be good.
Hey, on. Yeah, here's my question.
Uh-huh.
It says it's similar to what we were talking about, but it's number 17. I did it already, but I still wasn't sure about it. It's on the same worksheet too that you're on. It's on 17, number 17.
Number 17.
You got time.
Can I ask a question real quick?
Hold on a second.
So it's saying which electron orbital diagram is written correctly for an atom without any violations. So it's just asking which one looks correct.
Right.
So as we discussed earlier, you can see the first one does not look right.
Yeah, because it's missing one from the left side of the box.
This one does not look right. Why does this one not look right? B?
Because they're both going down and they shouldn't be going down.
Yeah, convention is that you always write the first one up. Then this one is also wrong because you have both filled in the same box, although there is more space. This one is also incorrect because these are not paired. We are putting electrons in here. First, these should have been filled. 1s should have been filled. 2s should have been filled. So only the last option is right.
You're right. And it's correct because the P's are going up, right? The protons.
Right.
And the S's, one's going up and one's going down. That's why that one's correct, right?
Yes. So 1s is filled, 2s is filled, and 2p is filled. with one box at a time, both pointing up.
Hey, just wondering, Mon, like with 18, I understand the ground state configurations, but
Right.
this one was a little all over the place for me. I understand that fluoride has 9 atoms, right?
Right.
But how come it's D? Because I'm counting it and I only see 7.
Right. Do you
Because there's
notice
5
that
P's.
there's helium written here in the front? And I taught this in the class. This is
Right.
the abbreviated way of writing electronic configuration
Right.
because helium is 1s2. So instead of 1s2, the way you can write the electronic configuration for the atoms is you can write the noble gas first,
Uh-huh.
and then whatever your atom has extra than the noble gas, you just write that.
Right.
This is called This is called an abbreviated electronic configuration.
Okay.
So helium has 2 electrons, and then there's 2 and 5, 7 shown here. 7 plus 2 is total 9. So
Right.
when
Okay.
you're counting this guy, don't just count these 2 that you see, but also helium, which has 2 electrons.
Well, yeah, that's what I'm asking because I don't want to make that mistake on the final or something, you know.
So on the exam, if the question says that you need to write abbreviated version of electronic configuration, that's the only time you're going to use these Nobel gas and put these brackets. If the question just says write the electronic configuration, then you write the detailed one like you learned in the class, where you start from 1s2, 2s2, and so on.
Mm-hmm.
Sounds good.
No.
Let me
No.
put it for you here. So for, let's say for sodium, okay?
Right.
Sodium has 11 electrons. If I say write the electronic configuration, you just do this: 1s2, 2s2, 2p6, 3s1.
Right.
If I say write the abbreviated electronic configuration, then you look at the periodic table and tell me which noble gas is before sodium.
Neon, right?
Neon. So you're gonna label neon first, make a bracket like this. Neon is 10 electrons, which is 1s2, 2s2, 2p6. So neon basically has taken all of these electrons, and you're left with 3s1, so you just say 3s1. So both of these are electronic configurations of sodium. One is the abbreviated version, and one is the complete detailed version. So the first that we wrote is the detailed one, this one, and this one is the abbreviated one.
Mon, I have another question, if that's okay.
Sure.
Yeah.
Yeah, same worksheet or?
Yeah, same worksheet. It's one of the ones towards the end. So either 37 or 38.
Okay. Where the question is saying electron is going from 6th floor to the 1st floor,
Mm-hmm.
and it's asking for wavelength.
So that's 1 over lambda, right? Or no.
I mean, you're going to find lambda, but we know the formula you're going to use has 1 over lambda, you're right.
Mm-hmm.
Right, so you're going to use that formula that you learned. Again, you'll be given these formulas, so you don't have to memorize them.
Oh, okay.
So you're going to just find your lambda, 1 over lambda first, and then switch it to find lambda. And then we know that RH value is given to us, which is 109618, and this is in centimeters. So remember,
Okay.
we're going to get will be in centimeters, will not be in meters or nanometers. Remember, it's in centimeters.
And why is it? So it's to the -1 because it's on the denominator, right?
Right. Because
Okay.
centimeter -1 means it's actually sitting in the bottom.
Okay.
Yeah, we just bring it up and make it -1. And then it says 1 over n1 squared minus n2 squared. Here I'll say don't confuse yourself,
Mm-hmm.
and just plug in any number you want.
Oh, really? It doesn't have to be positive?
At the end, make your answer positive. That's it.
Just no matter what, just change it
No matter
to a
what.
positive.
See, your number
Okay.
is going to stay the same. If you get negative answer, ignore negative. If you get positive, you're already good.
Okay.
Okay. So what I'll do is 1 over 6 square over 1 over what floor is going from 6th floor to 1st floor? 1 over
Yeah.
1 floor, right?
Mhm.
So now you just plug the whole thing into the calculator. What is 1 over 6 square minus 1 over 1 square? Minus 1 over 1 square is 1. 1 over 36 is how much?
1 over oh, so okay, so you actually divide it out.
Yeah,
You
that's
don't
why I never do that least common thing. I mean, I
oh,
would
okay.
divide them. 1 over 36 is 0.0277 and repeats.
What number is this?
Mhm.
This is number 37.
37?
Yeah. And 1 over 1 square is 1.
Mhm.
So you see how my number is going to be negative right now? But
Yeah.
I'll just ignore the negative. That's all we're going to do.
Okay.
So this number is actually, I mean, this number is, it's negative, but I'm going to ignore negative. This number is 0.9722. So this number times this number is 109618 per centimeter. Is this making sense?
Yeah.
Okay.
So it's
So I'm just going to multiply these numbers.
and it gives you 10,000
Oh, nine,
well 106,581.
580.
That's what I got.
Why am I seeing a little different number? I'm seeing
Oh,
7.
I can
Maybe I rounded it off.
so 0.9722 times 109,618. Oh, I got a different number. So 106,570.
70, this is what I almost get. So something like this.
Oh boy.
Okay.
Now,
It's close
this is
enough.
over lambda, right?
Yeah.
And we want to find lambda. So lambda is going to be over this number.
Uh-huh.
So now 1 divided by 106,573.05. This gives me
Oh, then you divide it again. Okay.
0.000933832. Are you guys getting that?
938. Yeah, I got it. Yeah.
And this is in centimeters, so you got to change it to nanometers. That's what the question says, right? Change it to nanometers. Answer has to be
Yes.
nanometers. So I have to change centimeters to nanometers. So this we should know the conversion on how to convert this. So we got 0.000093832, right? And this is
Uh-huh.
centimeters. We're gonna go from centimeters to nanometers. Which one is a bigger unit?
Centimeters.
This guy gets 1. And centi is
Yeah.
sent for -2, nano is sent for -9. So the gap is 7, right? Jumps are
Yeah.
7. So that means you're
Mhm.
gonna move this guy
To the right 7 times.
1, 2, 3, 4, 5, 6, and 7. So the answer should be 93.832 nanometers. And the answer is actually 93.8.
Okay, cool. So you have to divide it. You can't leave your answer in 1 over
Yeah, no, because
whatever. You have to.
for lambda, right? It says light with a wavelength of.
Uh-huh.
Not saying with 1 over wavelength of, right?
Okay.
Right.
Yeah.
Right. So you have to find the wavelength, and wavelength is lambda.
Okay.
Okay.
So it doesn't matter, no matter what. With anytime you get 2 ends, you just put them in whichever
Right. So
spot.
if you had like here,
Mm-hmm.
if you had done 1 over 1 square minus 1 over 6 square, you would have just got a positive number, and we already wanted a positive number.
Mm-hmm.
Now, the thing that you got to remember is the delta E. If the question was looking for delta E in the same scenario,
Mm-hmm.
and this was the formula, here this is an initial and n final square. So here you cannot just put any number. This has to be where you started, and this is the final.
And it says it started on one floor and went to another floor, right?
Right. Like if you just see the same question.
Mm. From N6
Electron
to
and
N1.
hydrogen atom moves from 6
Okay.
to 1. So
Okay.
from 6 to 1. Right? So my initial is 6 and my final is 1.
Okay. So we'll have a question kind of like this, like where they're connected.
Right, right. And then maybe, yeah, like you see this question?
Yeah, like when we did earlier.
Yeah, number 36.
Oh, we didn't do that one actually.
Yeah,
We
so
did
it's
something
looking
different.
for energy.
Okay.
Electron is going from second to third floor.
Mm-hmm.
So then you have to use this equation, delta E equation. And then your initial is going to be number 2.
Mm-hmm.
And final is going to be 3. So that's how you're going to plug them in.
And then K is a constant that we're given.
K is a constant, right?
Okay.
Right. Do you know that the constant K is 2.179 times 10 to the power negative 18 joules.
Okay.
Also, you can notice here, you see the answer is B,
Yeah.
is this number,
Mm-hmm.
not the negative. You see that? The answer is B, not C.
Yeah.
And this is actually true. You can see here, electron is going from second floor to the third floor, right?
Mm-hmm.
That means it will need energy because it's going from second floor to third floor.
Okay.
If it needs energy, it has to be positive. It has to be
So endothermic. Okay.
At the end, you can also make sense of your answer.
Yeah. Okay, that makes sense.
Right. So, question. There was another question. No, you don't need to remember any of the constants. You will be given constants and the formula. So not just the constant, you'll also be given the formula that delta E is K 1 over initial square minus final square. 1 over lambda is R 1 over N1 square minus N2 square. So you're given formulas and the constants. All right. Questions, guys?
Oh yeah, I'm trying to see how you did number 37, but you went a little fast, honestly.
I mean, these problems are not at all hard if you know what equation to use.
Okay.
So if you read the question is asking for if the electron goes from N6 to N1, the wavelength is going to be how much? The only equation that we learned that connects that is this equation. This equation right here. 1 over lambda is RH 1 over N1 square minus 1 over N2 square. RH is a constant. You're given this number. And then you're given here that it's going from 6th floor to the 1st floor. So you just plug in those numbers here. After that, it's just math. You're solving everything. You got 1 over lambda equals that number. Again, we want to find lambda, so we need to flip this guy. Lambda, we switched it. So 1 over lambda became lambda, so that's why this side was flipped. And we just got the answer. The answer that we got is in centimeters. And we wanted to change it into nanometers, so we just did that conversion here.
Okay.
So if you've done a question like that before, then you're just going to use this math. If you haven't done a question like that before, then read the question carefully, and then rewatch this video, and then this is the formula you're going to be using, or also look into your lecture notes. You're going to find that we learned 2 equations which are very similar. One is this 1 over lambda 1, which is this one. And then there's a very similar one, delta E is K 1 over Ni square NF square. The 2 different things that you're finding here you're finding energy. Over here, you're finding lambda. That's what you got to remember. Okay? But if the question is looking for lambda, you use this. For delta E, you use this.
Okay.
Right? And then you got to remember that you have Ni is initial, NF is final. Here, it doesn't matter. Your answer just has to be positive. That's what matters. If you get negative number, change it to positive. That's it.
Is that for all of these?
For all the lambda ones, yes. For energy, you cannot decide the chart, the sign. You make values tell you the sign, so you have to follow initial and final.
And then you double check based off
You
what
can
the
double
question
check
says.
Yes, yes. If you did everything right, it will be correct.
Yeah.
So it should be good. But here you cannot switch signs based on, I mean, you don't always make them positive or always make them negative. It depends on question to question. If you plug in the right values, then you will get the right answer. Right? Guys.
Yeah, let me look real quick. Like on 11 through 12 on this worksheet, is it similar to the one I was asking you earlier about the electronic configurations? Because it says the answer was chromium for 11 and 12.
Right. So here, krypton has how many electrons? Kr is krypton, right? Kr has how many electrons? Look into
KR has, where is that at? I'm looking at
36 electrons.
36 electrons. And then 36 or no?
Yeah, it's 36. That's krypton, right?
Yeah.
It says 36.
So it's
Yeah.
36, right? So 36.
Mhm.
And then this has 1 electron and 5s and 5 on 4d. So krypton has 36 plus 6, right? 1 plus 5 is 6. 36 plus 6 is 42.
Yeah.
So who has atomic number 42 on periodic table?
Mobilium or mobilium?
Molybdenum? Mo. Right. So let's
Yeah, it does.
periodic table. So krypton has 36. And this guy has 6 more electrons. So you after krypton you go 1, 2, 3, 4, 5, 6. Molybdenum Mo. So that is the answer.
Oh, okay.
But again, don't expect multiple choice question on these questions. You might see 1 or 2, but again, when you're learning electronic configuration, I'll suggest you guys to actually learn them by writing down the whole electronic configuration like we just did for sodium. 1s2, 2s2, 2p6, 3s1. I'll suggest you to do that for all first 30 atoms, and then their positive charges and their negative charges.
Okay.
Okay.
You understand all of that very good? All these electronic configuration questions are too easy.
Then it's the same thing too with the Cronian one, right?
Which chromium?
12, number 12 one, same thing.
Yeah, it's same thing, yeah.
So that doesn't seem so bad. So you recommend we focus a lot on this chapter 7 and 8 and on 3 and 4, and we should be fine for the final random one?
Yeah, if somebody gets this, I will say they'll get a very good score. If you get 6, 7, 8, and 3 and 4, yeah.
Yeah, because I'm starting to get 6, and I get 3 and 4, but 7 I gotta still work on, but it's coming though.
Right,
so.
right.
Another thing too, I'm on. I sent you an email, but I don't know if you got it or not. I sent you an email about.
Yeah.
But it involves your office hours tomorrow.
Yes.
Did you get it?
Yes.
Okay. Because I want to meet you tomorrow and let's probably discuss.
Sure.
Class stuff. So. All right. Anybody else have questions? I think. I don't know if anybody has some questions. Guess how many minutes do we have left? Like 5 or 4?
5
or how many? So to write them out basically in electronic configuration, you want us to just write it out like how you did with sodium on your scratch work?
Yeah.
So will that most likely be like a free response question, Amar, or where do you think?
Free response.
You'll say, oh, can you write out sodium or nitrogen or something like that, right?
Right. Anything from first 30 atoms.
Okay.
And remember, not just the atoms, but also the ions.
Right. What do you mean by the ion and numbers? What do you mean by that?
Like for sodium, I could ask you sodium, or I could ask you sodium plus. For oxygen, I could ask you oxygen or oxygen -2.
What would it be if
for
it's sodium plus or something like that? Or
sodium plus means you remove 1 electron. Oxygen -2 means you add 2 electrons.
okay.
And then for potassium, I could ask you Kip. For scandium, I could ask you Fe+2. For iron, I can ask you Fe+2 or Fe+3 or just Fe. So you should know all of them.
Okay.
Hey, Amon, if we're taking chemistry next semester, what's something that we should go over? Obviously, like nomenclature, but what's something else that's...
For the 1 or 2,
Yeah.
it's a different class for sure, but I'll suggest have a good understanding of thermal.
Okay.
Are you planning to take OChem as well?
Yeah.
For sure, chapter 6, 7, 8.
6, 7, and 8.
Chapter 7, big time.
Yeah.
So Lewis structures.
Okay.
That is something very useful for organic chemistry. Nomenclature, actually, not that much. I mean, yes, you got to know your acid base, and then types of reactions.
Okay.
That's what I would recommend.
Again?
Types of reaction, titration, and then Lewis structure. Those are some important topics that
Okay.
go. Yeah.
Yo no lo quité. Yo no lo puse. Un pedo.
Polyatomic ions, do we need to know how to write electron configuration for that? No.
Yeah.
So for writing electronic configuration is only for atoms or ions, not for molecules.
Okay.
For Lewis structure, yes. For Lewis structure, you need to know molecules like CO2 and also CO3 negative. Yes, Lewis structure, polyatomic ions, and the on test. But just the electronic configuration, no, it's just atoms and ions, not polyatomic.
Ya sí, ahorita voy a ir cantados otra vez. Me voy a ir a echar una cantidad.
All right, questions, guys?
But no, but that's, and then if we have any more, we can see you tomorrow, right? Come on.
Uh-huh.
You're there from 12 to 1, of course.
Yeah.
Okay. All right. Sounds good, Amon. All right.
Okay.
We'll see
Thanks,
you.
Amon. Appreciate it.
Amon, good question. When will you said that the labs that we need to do are 22, 23, and 24, right?
Yeah, they're
Practice
due,
for this exam?
yeah, they're due before finals week exam, so not this week, but next week.
Okay. So you recommend we get started on them this week?
Yes.
Okay.
Or today.
All right. Okay. All right, Amon.
Lewis
Thank you.
structure, you guys will study Lewis structures more tomorrow. So make sure you guys study Lewis structures as well. Otherwise, tomorrow's lecture is not going to make sense. So make sure
All right.
you recap.
Yeah, we're working on that.
Yeah.
All right. Thank you, Amon. Have a
Right
good
here.
one.
Right.
Thank you.
Bye.
Good one.